Hello students, now let us take composite functions. It is just another type of functions. Okay, so till now we have seen what is one function, what is onto function. The next type of function is composite function. In the name itself it is there. Composite means it is a mixture of two or three things. Like you have studied in chemistry, composite means it is a mix of two things. Here it is a composite function, so therefore it will be mix of two or more functions. Let us understand what is this composite function. Okay, so for that let us take a set A and let us say set B is there and f is a function which is mapping from set A to set B. So this is how the function is there. If there is an element x, then it will map to f of x. Correct? Okay. So next will be, let us take another set C. Now let us define a function g from B to C. Okay. So this is what we are doing. Now this g, what will it do? Very simple. As f is doing, if x is there, it will take to f of x. Right? So in the same way, if f of x is there and g is the function, then what will it do? It will take g of this, like it will take this to g of this, isn't it? The f is taking this to f of this. So in the same way, g will take f of x to g of f of x. Okay, fine. So on the whole, we have two functions here, f which is mapping from A to B and g which is mapping from B to C. So on the whole, because of f, x went to f of x. Because of g, f of x went to g of x. So x went to g of f of x. Correct? On the whole, because of two functions, x went to g of f of x. So if you are taking the total effect on x, x went to g of f of x. So because of two functions, this is the result. So therefore, this is a composite function. As I told you, composite means it is like a mixture of two things, isn't it? Like two functions are acting together. So first f is acting, next g is acting. The way you write is g circle f. This is a composite function. Simple. There are two functions which are acting. That's all. Okay. So let us study the same thing. Let f is a function which is mapping from A to B and g is a function which is mapping from B to C. Then the composition of two functions f and g defined by g circle f is mapping from A to C given by g circle f of x is equal to g of f of x. Now here, till here everything is very simple. If you are defining a function f mapping from A to B and g defined from B to C, then there is a function g circle f which will map from A to C. And if you are giving an input x to this, the output will be g of f of x. Simple. Okay, fine. Okay. So now we have to understand some small things here. Let us do one by one. For g circle f of x, okay, the same thing. This is a function. This whole thing is a function. If you are giving x, where is it going to? G of f of x. So here, first we can see that x is being taken by f of x. X is being taken by f of x. Now, whatever is f of x, that is the input for g. That is what is happening here. Okay, fine. Okay. So, because first x is taken by f, so therefore x should come from the domain of f. Isn't it? This x is first taken by f. So, therefore, this x should come from the domain of f. Here also we can see x is coming from the domain of f. So therefore, this is important for a composite function. For a composite function, domain will be decided by inside function. Domain will be decided by inside function. Okay. Just have this in your mind. Because first, inside function is taking x. So therefore, first that should be defined. If f of x is defined, then f of x will be taken as an input for g. So if f of x itself is not defined, then what will be the output for this whole function? There will not be any output, isn't it? If the inside function is not defined, then what will be the input for the outside function? If x is not going to f of x, then what will be the input for g, right? So therefore, domain of a composite function will be decided by the inside function. In the same way, the outputs are given, means final output is coming out of g, isn't it? Finally, g is acting on f of x and it is taking to g of f of x. This is our final output. So therefore, the final outputs are decided by the outside function. So simply now I will say that codomain of composite function will be decided by outside function. Will be decided by outside function. Outside function. So now we are very clear why we have G circle F mapping from A to C. Even without all of this, even without this diagram, when I see this, I can say that this function's domain will be decided by F. Whatever is the domain of F, that will be the domain of composite function. Whatever is the codomain of G, that will be the codomain of this composite function. So codomain of G is C. So therefore we have G circle F mapping from A to C. And after that it is very simple. Here we have a function G circle F. If we are giving an input x, then the output is G of f of x. Now here we have for all x belonging to A. Now this x, just now I told you this x should come from the domain of inside function. So therefore, what is the domain of inside function? Set A. So therefore, this x, which is the input for this composite function, should come from set A. So therefore, for all x belonging to set A. Is it clear? Right? So x should come from set A. This much is clear. But why should it be for all x belonging to A? Obviously, if for all x belonging to A, there is no output. Okay, if there is no arrow coming out of this, then this will not be a function, correct? Isn't it? So if you don't have every element of domain having one arrow coming out of it, this will not be a function. So therefore, here we have for all x belonging to A. Clear? Okay. So on the whole, we understood that codomain of one function and domain of other function should be same for composite function to be defined. But in IDJE, we will define functions even when the codomain of one function and domain of the other function is not same. That we will deal there. For now, let us understand what is there for NCERT. If the codomain of one function and domain of the other function are same, then we can define a composite function. Okay, in a composite function, the domain will be decided by inside function, codomain will be decided by outside function. Okay, fine, that's all. Other than that, it is very simple. There are two functions which are acting together and you have a final output. Here it is G circle f of x. Sorry, G circle f is the function and the final output is G of f of x. Okay, so now let us take the next part. Let us take an example. F is a function which is mapping from set A. Sorry, here we have 2, 3, 4, 5 and codomain is 3, 4, 5 and 9. And G is a function which is defined from 3, 4, 5 and 9 to 7, 11, 15. B functions defined as f of 2 is equal to 3, f of 3 is equal to 4, f of 4 and f of 5 is equal to 5. G of 3 is equal to G of 4 is equal to 7 and G of 5 is equal to G of 9 is equal to 11. Then find G circle f of G circle f. Now, if they're asking what is G circle f, then it is very simple. Now, how do you find what is the meaning of find G circle f? It simply means that what is the output for different inputs. Okay, so if you want to find what is G circle f, then you want to find what is G circle f of x. For different inputs, what is the output? So before we get into this, for clarity purpose, we can make a diagram. Okay, so here we have composite function. So let us take 3 sets. Now we want to define G circle f. So in G circle f of x, this is nothing but G of f of x. So here first f is acting on x. Here first f is acting on x, and after that G is coming. So therefore first f will come, next G will come. Okay, now here we have 2, 3, 4, 5 set, because the domain of f is 2, 3, 4, 5 and codomain is 3, 4, 5, 9. 3, 4, 5 and 9. And here for G the codomain is 7, 11, 15. Okay, so now we want to do the mapping. Now what is given here? F of 2 is equal to 3. So if 2 is the input for f, then the output is 3. So let us do the mapping. So this is the mapping. Next, f of 3 is equal to 4. And f of 4 and f of 5 both are 5. So therefore this is how the mapping happens from f. Okay, so next after that, G of 3, G of 4 is equal to 7. So G of 3, G of 4 is equal to 7, and G of 5, G of 9 is equal to 11. So on the whole, this is the mapping that is happening. Correct? Okay, so we want to find what is G circle f of x. So if you are talking about G circle f of x, then it is very simple. If you want to find this function, what you want to do is, you want to find what are the outputs for different inputs. That's all. Okay. So let us say, for example, this is there in our rough. Okay. This whole thing is there in our rough. From here, let us write the solution. So the solution is, we want to find G circle f or G circle f of x at x is equal to, now x should come from the domain of inside function, which is domain of f. So here x should take values 2, 3, 4 and 5. At x is equal to 2, we have G circle f of 2 is nothing but, I can write the same thing as G of f of 2. Now what is f of 2? F of 2 will be 3. Okay, so always first find the innermost function. Okay, so first find what is f of 2, the innermost thing, and then from there you keep coming outside. So G of 3 is equal to 7. Fine. Next, at x is equal to 3, G circle f of 3 is equal to, as I told you, this can be written as G of f of 3. Replace the innermost function. So here we have G of f of 3 is 4. Next, G of 4 is 7. So here we have 7. Next, after that, let us take the next part. At x is equal to 4, we have G circle f of 4 as G of f of 4. This is equal to G of f of 4 is equal to 5. So what is G of 5? G of 5 is 11. Okay, and in the same way, at x is equal to 5. Now this is very simple. We understood how to do it. We have to go to the innermost function first and then find the answer for this one and then come out gradually. So f of 5 is 5 and G of 5 is 11. So that's it. We have taken all those values of x which come from the domain of this function. Domain of this function is decided by the domain of inside function. We have taken all those values of x. We found out the outputs. So this you have written, isn't it? So here, because of no space, I wrote it up. So on the whole, we have completed. So that's it. So this is what is our answer for this question. We found out what is G circle f of x. For different values of x, what are the outputs. X will come from domain of f. This we have clearly understood. There is no problem at all. Correct? Let us take the next question. Now, here we have find G circle F and F circle G if F is mapping from R to R, G is mapping from R to R, f of x is equal to cos x, g of x is equal to 3x square. Show that G circle F and F circle G are not different. Now here we have two functions, F circle G and G circle F. Now what are these two functions? First of all, we have studied what is G circle F, but we did not study what is F circle G. Now, let me ask you, you can yourself say what is F circle G, what is it going to be? In the same lines as G circle F, we have, for G circle F, we have written this as G of f of x, correct? So if you're talking about a function f circle G of x, then this will be nothing but f of G of x, isn't it? Correct? Okay. So now in this question, in this example, can we define f circle G? Can we define f circle G? On what will it depend? On what will it depend? Very simple. If you are having G of f of x, x should come from the domain of f. Fine. Next, whatever is the outputs of f, okay, whatever is the codomain of f, that should be the domain of G. So therefore, if the codomain of f is domain of G, whatever are the outputs of f, that will be in the domain of G. Whatever are the outputs of f, they will be in the domain of G. So therefore, the whole function will be defined. Again, I am saying the outputs of inside function are inputs of the, here we have seen, see, the outputs of the inside function will become the input for the outside function, right? Okay. So if the output of inside function will become input for outside function, so output of f should be there in domain of G. Only then this whole function will be defined. Now let us come here. If you are seeing here, which is, let us say, f circle G of x, now this will be f of G of x. So the output of G of x, the outputs of G of x should be there in the domain of f, which is not happening here. Is it clear? In this case, we have output of f as input for G. But in this case, where you have f circle G of x, the output of G is not the input for f. So therefore, here this will not be defined. Here means in this example, this will not be defined. But let us come to the place where we want to see. Okay, before that, here will it be defined? Will f circle G of x be defined in this case? You tell me. Now, is the output of G input for f? Is the output of G input for f here? Output of G is this set and input of f is some other set. So therefore, here f circle G is not defined in this example also. But let us come here. In this case, here f is mapping from R to R, G is also mapping from R to R. So if you are talking about f circle G of x, in this case, then it will be defined because the outputs of G are all real numbers. And the same set is the domain of f. So therefore, the codomain of G is same as domain of f. So therefore, f circle G will be defined. Okay. So in the same way, let us see if G of f of x will be defined. Okay. The outputs of G. Okay. So I am loosely using the terms outputs and codomain. All of us know range and codomain are different. But for now, let us just understand in a rough way. Wherever you find the outputs of f, are they inputs for G? Wherever you find the outputs for f, that is codomain of f, are they inputs for G? Yes. So therefore, here G circle f is also valid and f circle G is also defined. Clear? Okay. So here, let us find out what is f circle G of x and G circle f of x. Okay. So first, let us start with G circle f of x. Okay. Consider G circle f of x. Now this can be written as G of f of x. Now just before, we have done a problem where we wanted to find a function and we had different values of x. X is equal to 2, 3, 4 and 5. Because these x should come from the domain of inside function. Finite number of values. Finite number of values means 2, 3, 4, 5. 4 number of values itself. But here we have x coming from the domain of inside function, and that is all real numbers. Infinitely many real numbers are there. Then what to do? Very simple. See here, the same procedure as we were doing before. Just replace the innermost function first and then gradually work outwards. Okay, come outwards. So here also, first what I will do is I will replace what is f of x. What is f of x? Cos x. Okay, so I will write cos x. Next, after this, what is g of x? 3x square. Correct? What is g of 1? 3 into 1 square. Whatever is there here, you write 3 into that, and for this you put a square. Simple. So here this will be, because cos x is there here, I will write 3 into cos x, and for this cos x I have to put a square. So this is what is G circle f of x. Next, consider f circle G of x. Now what is f circle G of x? As everybody, all of us know, it can be written as f of G of x. First, x will be taken by the inside function. So that is what is happening. Its output is taken by the outside function. So therefore, you can write, whenever you see this one, you can write it like this. Okay. So after this, what is g of x? G of x is 3x square. So we have to replace first the innermost function, and from there we have to work outwards. So f of x is cos x. F of 3x square will be cos of 3x square. Now what is being asked here? They are asking, show that G circle F is not equal to F circle G. Now here we have G circle F as 3 cos square x and F circle G as cos of 3x square. Are these two functions same or different? Certainly they are different. 3 cos square x and cos of 3x square are anyway different, isn't it? Right? This is a different function. That is a different function. Nobody will say that 3 cos square x is same as cos of 3x square, right? Okay. So therefore, F, G circle F is not equal to F circle G. Simple, right? These two are different functions altogether. So that's all. So from here, what all we understood? We understood that G circle F can be defined, F circle G also can be defined. All that which matters is the codomain of this function and domain of this function. If they are same, then we can define a composite function. Codomain of inside function and domain of outside function, if they are same, then we can define the composite function. Simple, right? Okay. Next, one more thing is, wherever you find G circle F, this is a function. So therefore, you can write, means you write F or you write F of X. It is the same thing, isn't it? You're talking about the function. So for this input is X. So you're talking about the function G circle F. For this input is X. Whenever it is written, you can write this as G of F of X. Okay, fine, clear? Okay. So till now, what all we understood? We understood what is a composite function. For a composite function, domain will be decided by the inside function. Codomain will be decided by the outside function. Next, when can you define a composite function? When codomain of inside function and domain of outside function, when codomain of inside function, domain of outside function both are same. Here also, when codomain of inside function and domain of outside function, both are same. But as I told you in IIT JEE video, we will see cases where codomain of inside function and domain of outside function are not same also. Even then we can find out the composite function. That we will deal in that video. Okay, so that is what we have discussed. Let us take the next part. So now let us take the next question, and that is find G circle F and F circle G if f of x is equal to mod x and g of x is equal to mod of 5x minus 2. And the second question is f of x is equal to 8x cube and g of x is equal to x power 1 by 3. Now it is, see, let us first take this question. Now what is the difference between this question and this question? Everything is the same. Here there is some function f of x. Here there is some function g of x. We should find what is G circle F, let us say. Of course, we find out what is F circle G also, but let us say we found out what is G circle F. That is the question here. Now, what is the difference here? We have one function, we have other function. We should find F circle G, G circle F. Same thing, right? Okay. So here also we are finding these two functions, and here also we are finding these two functions. Now, what is the difference? The difference is there is no domain codomain given here. Here clearly it is mentioned f is mapping from R to R, G is mapping from R to R. So therefore we clearly did the problem. Here nothing is mentioned. Then what is the domain? What is the codomain? Is F circle G defined? Is G circle F defined or not? This, how do we make a conclusion? Just before we have discussed, for F circle G to be defined, the codomain of this function and domain of this function should be same. But here nothing is mentioned. If nothing is mentioned, you also don't need to worry anything. Just find out what is F circle G and G circle F. Okay, this as far as boards is concerned or CET is concerned, in general, even if it is in JEE, no domain and codomain is mentioned. You don't need to worry about it at all. You can normally you can normally find out the answer. You can find out what is F circle G and what is G circle F. Okay, let me tell you that if nothing is mentioned, that means F is mapping from domain of the function to range of the function. If nothing is mentioned, and G is also from domain of this function to range of this function. Okay, fine. If you understand it, that is good. If you don't understand it, that is also fine. So we should just simply solve the problem as if, like, it is defined. Means F circle G is defined and G circle F is also defined. Simple. Okay. So if nothing is mentioned, that means if domain is normal domain of the function and codomain is range of the function. This we will discuss in IIT JEE part. Okay. For now, let us keep it simple. Nothing to worry at all. Whatever it is that, anyway, we will discuss in IIT JEE part. Nothing to worry. Okay. So now, as I told you, if nothing is mentioned about the domain and codomain, normally we can proceed. Nothing to worry. So therefore, let us take the first question. Okay. We should find G circle F and F circle G. Just before we have discussed, G circle F is same as G circle F of x is same as G of F of x. However you want to write, you can write. All mean the same thing. So here, G circle F of x, this you can write it as G of F of x. First you replace the innermost function and then you come outwards. So F of x is equal to mod x. After this, it is very simple. G of x is equal to mod of 5x minus 2. So what is G of p, let us say? Mod of 5p minus 2. Whatever is there here, you put it in place of x. So here mod x is there. So mod of 5 mod x minus 2. Simple. Found out. That's it. So this is G circle F of x. What is F circle G of x? This is nothing but F of G of x. Now you replace the innermost function first. So F of G of x is nothing but mod of 5x minus 2. Clear? Done? Okay. We know what is F of x. Now we want to find what is F of this thing. Very simple. If whatever you want to put it here, you put it here. Outside you put mod. That's all. So whatever is there here, you write that, and outside you put a mod. Simple. Okay. So now this can be further simplified, isn't it? Right? Let us say now let us discuss this. If you have mod of x. Okay. So even before coming here, let us discuss mod x. What does mod x do? Sorry, what does mod do? If x is negative, it will make positive. If x is 0 or positive, whatever is there here, it will give as it is. So therefore, mod x is equal to x if x is greater than or equal to 0. Inside the mod, whatever you have, if it is 0 or positive, whatever is there here, you can write it without the mod. If this is negative, let us say, then you put one minus sign. This has to be done when x is less than 0. Clear? Okay, fine. So some students, you might be having a doubt that if x is less than 0, where is the negative sign here? See, this is x. X can be positive, x can be negative. And minus x can be positive, minus x can be negative also. It depends on x. That's all. If x is minus 5, let us say, then this whole thing will be positive. If x is 5, let us say, then this whole thing will be negative. So in the same way, here as well, if you say x is less than 0, if you put minus x, that will become positive. That is why we have minus x here. Mod x should always be positive, right? Or 0. If this is 0, then output will be 0. So on the whole, if this is negative, then put a negative sign here so that this whole thing will be positive when you remove the mod. So that's all. So here, if you have mod of x, then already this mod of x is 0 or positive, isn't it? Mod of x is always 0 or positive. From the graph, also we can see that this is mod x graph. Okay. Again, I am saying minus x does not mean this is negative. X is less than 0. That means minus x will be positive. Okay. So that's all. So mod x is 0 or positive. This inside thing is 0 or positive. If the inside thing is 0 or positive, then you can write that without the mod, isn't it? So if the inside thing is 0 or positive, this much, then you can write this without the mod. Now, which mod we have to remove? We have to remove the outside mod itself. Obviously, because of this inside mod, this whole thing, which is mod of 5x minus 2, this whole thing has become 0 or positive. So the outside mod is not doing anything. So you can remove it. But inside mod we cannot remove. Inside mod, we are not sure 5x minus 2 is positive or negative. Clear, isn't it? That depends on x. But mod of 5x minus 2, we are very clear. That is 0 or positive. Simple. Okay. So that's it. So this is how we have completed the first question. There is no complication at all here. As we were doing before, we are doing the same thing. So let us find g circle f of x. This is nothing but g of f of x. Now you replace the innermost function. Innermost function is f of x, that is 8x cube. So therefore, g of 8x cube, g of x is x power 1 by 3. Whatever is there here, you take it and put power 1 by 3 on the top. So 8x cube is there here. For this, I have to put power 1 by 3. Simple, right? So now, this can be written as 2 cube x cube whole power 1 by 3. And of course, this can be written as 2x whole cube whole power 1 by 3. Correct? Okay. So therefore, this 3 and this 3 is getting cancelled. We are getting this is equal to 2x. So g circle f of x is equal to 2x. Let us come to the this part, that is f circle g. F circle g of x. Now this is exactly the same as we have done before. Replace the innermost function x power 1 by 3, and in x, wherever x is there, you have to put x power 1 by 3. Correct? Okay. So therefore 8 x power 1 by 3, this has come in place of x, and one cube is there. So therefore cube is there here also. So therefore this 3 and this 3 is getting cancelled. So we have this is equal to 8x. Fine. So we have found out in the second question also what is f circle g of x and what is g circle f of x. Now let us take one more problem. Let us take the next question. So in this question, the question looks really, very big, but actually this is a very easy question. Okay. So to do this question, there are some things, if you know, then, it will be much more easy. Even if you don't know also, it is all given in the question. So let us first understand some things before coming into this question. Okay. So here we have, let us say for example, you have a function, some function. For this, the input is x and the output is also x. Fine. Okay. So there is a specific name for this function and this is called identity function. Very simple. In the name itself, it is there. Identity of the input is retained. Means whatever is the input identity, the output, the identity of the input is retained. Whatever is the input, the output is also the same thing. Okay, fine. Now, obviously, this x should come from the domain of f. Only then this function will be defined. So, for all x belonging to, let us say our function's domain is A. I am not interested in codomain for now. Domain is A. So, for all x belonging to A, okay, the same thing, which is an identity function, you can write it as IA. Okay. So, what is this IA? I means identity function and it is defined on set A. So, therefore, you are taking all the values of set A and you are mapping it, means because this is the identity function. So let us take here also A itself. So here we have A. So we have a function, whatever is the input, that is the output. This is defined on set A. So f mapping from A to A, f of x is equal to x. So this is called an identity function. Of course, this is defined on A, right? Okay. So you define by IA means identity function defined on set A. So for this function, inputs come from set A. Simple. Okay. So let us say, for example, you have another function, which is the same function, f of x is equal to x, but here the domain is some other set. Okay. And codomain is also the same set. So here also, whatever is the input, the output is the same thing, but this is a different function because this x which we have here is coming from a different set. So if you say f of x is equal to x here also, f of x is equal to x here also. Yes, that is correct. But this x is different from this x. This x is coming from, let us say, something like this. 4, 5, 6. 4, 5 and 6. 1, 2 and 3. So in f of x is equal to x, the x is coming from these values. X is taking these values 1, 2 and 3. So this x is not equal to this x. Clear? Here, whatever is the input, that is the output. Here, whatever is the input, that is the output. But this input values are different. These input values are different. So therefore, in that way, this is a different function. And because it is defined on set B, you are writing IB. Simple. Okay, fine. Okay. So how do you write the same thing? You can write this as IB of x is equal to x. Now, what is the meaning of this? X is coming from set B. Whatever is the value of x you take from set B, this function, whatever is the input, it will give you the same output. Okay. So therefore, let us write the same thing here as well. So let us just make some space. So here, IA of x is an identity function. So output is also x, and this x is coming from for all x belonging to set A. And in the same way, if A is replaced by B, with symmetry you can say it will be equal to x for all x belonging to B. Now, is it clear what is an identity function and on which set is it defined? Based on that, you give a name like this IA. Okay, there is no difference between this one and this one. Absolutely everything is the same. Just you by writing I or identity I here, you are giving more information. That's all. Okay, fine. Okay. So more information means it is the same information, just the way you're writing is different. That's all. Okay. So let us take the question now. So we understood what is an identity function. Show that if f is mapping from some set to some set. R minus 7 by 5 is one set, R minus 3 by 5 is another set. Now what is R minus 7 by 5? Very simple. Out of all real numbers, if you remove only one real number, that is 7 by 5, then that also will be one set. Real numbers is a very infinitely big set. In that you remove 7 by 5. Except that everything else you take it. On the number line, here you have 0, here you have 7 by 5, let us say. You remove this real number, only that real number. Then all of the other real numbers, if you have in one set, that is R minus 7 by 5. In the same way, R minus 3 by 5. Okay. So show that if f is a function which is mapping from this set to this set is defined by f of x is equal to something, and g is a function which is mapping from this set to this set is defined by g of x is equal to 7x plus 4 by 5x minus 3. Show that if f is this and g is this, then f circle g is IA and g circle f is IB. Just before we have discussed what is IA and what is IB. IA is identity function defined on set A and IB is identity function defined on set B, where A is R minus 3 by 5. So therefore this is A, and B is R minus 7 by 5. So therefore this is B. Okay. So in the same way, this is A here and this is B here. And here it is given IA of x is equal to x for all x belonging to A, and IB of x is equal to x for all x belonging to B are called identity functions on sets A and B respectively. So we know very well what is identity function. Just before, we have discussed this part. So, for a person who doesn't know also, they're clearly mentioning what is IA of x and IB of x. So we have to show, now what is the question saying? From here it is just information, means what is A, what is B and all. This much is the question. Show that if f is this function and g is this function, then f circle g is equal to IA and g circle f is equal to IB. You understood the question? Clear? Okay. So we have to prove that f circle g is identity function, g circle f is identity function. Simple. Okay. So how do we do? Exactly the same way we have to do here also. Okay. Consider f circle g of x. Finally, we have to prove that this is an identity function. Means if this is an identity function, whatever is the input, output should be the same thing. Okay. So let us do that. So this can be written as f of g of x. Replace the inside function first. So f of 7x plus 4 divided by 5x minus 3. Okay. So what is f of x? This thing. What is f of this thing? Wherever x is there, you have to put 7x plus 4 by 5x minus 3, isn't it? Right? So therefore, here we have 3 into 7x plus 4 divided by 5x minus 3. This has come in place of x, plus 4 as it is, divided by 5 in place of x. I will write the same thing, minus 7. So here we have 7x plus 4 by 5x minus 3 and minus 7. Okay. After this, we know, means what answer are we expecting? That also is very clear, right? So we have to take LCM and see if that is coming or not. What is the expected answer? Because this is an identity function, I have to prove that this is equal to x. Okay. We have to prove that this is an identity function. So I will expect this will come out to be x. Let us see. So here this can be written as 21x plus 12 divided by 5x minus 3 plus 4 divided by 35x plus 20, okay, divided by 5x minus 3 and minus 7. Now you take LCM. When you take LCM in the numerator, you will have, some numerator divided by 5x minus 3. When you take LCM in the denominator, you will have some numerator divided by 5x minus 3. So numerators, denominator and denominators, denominator will be same. So therefore we can cancel it. Clear, isn't it? If you have a by b divided by c by b, you can cancel these two, right? Or otherwise you can write it like this also. A by b, when it comes up, it will become b by c. So these two will get cancelled, a by c. you see it like this or like that, it is the same thing. Okay, so let us see here. So here we have, when you take LCM in the numerator, this will be as it is, plus 20x minus 12. A denominator 5x minus 3. After this, we have to take LCM in the denominator. So 35x plus 20 will be as it is, minus 35x plus 21 divided by 5x minus 3. So after this, as we have discussed, the numerator's denominator and denominator's denominator both can be cancelled. Now you can see here, minus 12 is there, plus 12 is there, and minus 35x is there, plus 35x is there. So on the whole, we have 41x divided by, here we have 41. So as we have expected, this is coming out as x. So we got f circle g of x is equal to x. So therefore, this is an identity function. Whatever is the input, we got the same output. So let us write the same thing after this. So till here, let me erase this part. So we got f, so therefore f circle g of x is equal to x. And where should this x come from? In the starting of this lecture, we have discussed that for a composite function, there it was g circle f of x. This x should come from the domain of inside function. Correct? Okay. So here, what is this x? This x is coming from domain of g. What is domain of g? This one. What is this? This is nothing but a. So therefore, for all x belonging to a. Clear? Okay. So this is an identity function which is defined on set A. So implies f circle g is a function which is an identity function defined on A. So that is what we have to show. So half of the question is completed. F circle g is equal to IA. Now if you want to find g circle f and you have to prove that this is equal to IB, what is the difference? Everything is the same. Just we have to find g circle f of x. We should prove that this is equal to x. And once you have that, this x should come from the domain of f. What is domain of f? R minus 7 by 5. What is R minus 7 by 5? B. So therefore, this x should come from the domain of inside function, which is B. So therefore, for all x belonging to B. So this is nothing but IB only. So if it is IB, that is what we have to prove. Correct? So therefore, the rest of the thing is also very easy. Just we have to, means calculation part will be little different, but the method is the same, right? So let us complete that also. So we have to find g circle f of x. Okay. So this can be written as g of f of x. Now replace the innermost function f of x, and that is 3x plus 4 divided by 5x minus 7. After this, what is g of x? This thing. What is g of this whole thing? Just wherever x is there, you have to put this, isn't it? G of p is 7p plus 4 by 5p minus 3. For a moment, consider this as if like this is p. So therefore, 7p plus 4 by 5p minus 3. So whatever is p, you replace it in the last. So when you do that, you'll get this. That is, in place of x, by 5x minus 7 and plus 4 divided by 5 into minus, from here 5 minus 3, right? 7 into whatever is there in place of x plus 4 divided by 5 into whatever is there in place of x minus 3. So here we should have 3x plus 4 by 5x minus 7. So after this, it is just calculation, because exactly the same thing we got before also. So there we have taken LCM, and finally we have shown that this is equal to x. So let us do the same thing here also. So this is 21x plus 28, 21x plus 28 divided by 5x minus 7 plus 4. This whole thing divided by 15x plus 20. This is divided by 5x minus 7 minus 3. So after this, just take LCM in the numerator, LCM in the denominator. Numerator's denominator, denominator's denominator will be same. You can cancel. Of course, we cannot cancel now. Obviously, isn't it? If you have a by b plus c divided by d by b plus c, I cannot cancel b and b here. First, I have to take LCM. Only then we can cancel, right? I hope it is clear, isn't it? We cannot cancel like this. We have to take LCM, a plus bc divided by d plus be divided by b. Is there any mistake here? This should be b. So now you can cancel. After taking the LCM, for the whole numerator, this is the denominator. For whole denominator, this is the denominator. Then we can cancel. So we understood, when to cancel. That is after taking the LCM. So once you take the LCM, this will be as it is, 21x plus 28 plus 20x minus 28. This should be divided by 5x minus 7. And of course, after this, 15x plus 20 and minus 15x minus 21. Is it? No, this should be plus 21. Plus 21 divided by 5x minus 7. So 21x plus 28 plus 20x minus 28. 15x plus 20 minus 15x plus 21. Perfect. So now let us cancel these two. Okay. So denominator's denominator, numerator's numerator can be cancelled. Here 28 is getting cancelled. Here 15x is getting cancelled. So on the whole, we have again 41x like before. But on the whole, we should get x. So that we are getting here also. So this is equal to x. So we found out what is G circle f of x. And we got this is equal to x. That means this is an identity function. So let us write the conclusion part. And that is G circle f of x. Therefore, we found out this. And this is equal to x. Of course, this x has to come from the domain of inside function. And the inside function is f. So inside function f domain is r minus 7 by 5. And that is b. So for all x belonging to b. So the same information certainly can be written like this also. So implies G circle f is an identity function defined on set B. So that is what we had to prove. So we have proved this one and this one as well. Now, what is the difference here? In the before question also, we found out G circle f, f circle G. Whatever is the answer, we have written. Here also, we have done the same thing. Actually, there is no extra new thing here. Just we have shown that this is an identity function. The way you have written finally is, you have written in the notation which is given here, IB, which is identity function. Otherwise, as I told you, this is a very easy question. By seeing, means just to see, it looks as if like this is a very big question. Okay, fine. So now let us take some CET questions on composite functions. So let us take CET questions. Okay, so the first question is, f and g are two functions. Domain and codomain are same for these two functions. Defined as f of x is equal to mod x plus x. And g of x is equal to mod x minus x for all x belonging to R. Then f circle g of x for x less than 0 is. Okay. So here we should find f circle g of x. And clearly it is given x is less than 0. Now by seeing mod x, all of this, nothing to worry. See, it will be very easy. You'll just understand in just a moment. So f circle g of x. I should find what is f circle g of x. Because this is a competitive exam question, I can also do it like, little quick. How do you want? Like first I'll do the quick way and then I will, properly write it so that even if you didn't understand something, you will be very clear with it. Okay. So I should find f circle g of x when x is less than 0. This is nothing but f of g of x. Of course, x is less than 0. What is g of x? This much. If x is less than 0, just before we have discussed, this is minus x. So already one minus x is there. That means this is minus 2x. Okay. So what is f of x? Mod x plus x. Okay. So we have mod of minus 2x minus 2x. Okay, so this is what is f of minus 2x. Now, because minus is there, I should not remove just like that. Because x is less than 0, minus 2x is positive. Because this is positive, so whatever is there inside, that can be written as it is by removing mod also. And this is anyway, means there is no mod here. Finally, minus 4x. So option B is our correct answer. Simple, right? Okay. So let us write clearly, formally, so that even if there is any doubt also, that should not be there after this. So f circle g of x. This is equal to f of g of x. After this, f of, what is g of x? That is nothing but mod x minus x. We want to find when x is less than 0. If x is less than 0, then inside thing is negative. When inside thing is negative, if you are removing the mod, just before we have discussed, this is equal to x for x less than or equal to 0, and this is minus x for x is less than 0. So if you are removing the mod, if inside thing is negative, put one negative sign and put whatever is there inside. So therefore, here if x is less than 0, then when you remove the mod, whatever is there, you write it, but put a negative sign, and already one minus x is there. So this is f of minus 2x. Clear? Okay. So because x is less than 0, this is clearly given here. So minus 2x will be positive, right? Okay. So whenever you have inside thing positive or 0, then when you remove the mod, nothing to worry, just write whatever is there, inside. So here also f of minus 2x, when you remove the mod, okay, first let us write like this, minus 2x minus 2x. Now when you remove the mod, it depends on the inside thing. If it is 0 or positive, then you can remove the mod and write whatever is there inside, right? Correct? Okay. So because x is less than 0, okay, in all of these places, x is less than 0. F circle g of x for x less than 0. For this, we are finding out, okay, for x less than 0. So because x is less than 0, this is positive. So therefore, if this is positive, I can remove the mod and write it like this. So minus 4x, very simple. So option B is our correct answer. Okay, let us take the next question. So here we have f is a function which is mapping from R to R. G is a function which is mapping from 0 to infinity to R. Is defined by f of x is equal to x square. G of x is equal to root x. Which one of the following is not true? We should find the one which is not true, which is false. Okay, what is f of g of 2? This is nothing but, in g means first we should come to the inside thing. What is g of 2? That is nothing but root 2. So f of root 2. And what is f of root 2? Root 2 square, which is nothing but 2. So this is correct only. F of g of 2 is 2 itself. Next, g of f of 4. What is this one? This is nothing but f of 4. F of 4 is 4 square, which is 16. What is g of 16? Under root 16, which is equal to 4. So this is also correct only. Next, g of f of minus 2. G of, okay, f of minus 2. What is f of minus 2? That is nothing but 4. So g of 4. What is g of 4? 2. So this is also correct only. So, even without checking also, we can say that this will be the correct answer. But let us do it. So g of minus 4. Now g of minus 4, how will it be defined? This we have root. So therefore, this is, actual answer is, this is not defined. Means, if you're actually giving the answer, that is not defined. But we want to take the wrong answer. So therefore, this is equal to 4 is wrong answer. Okay. Let us take the next question. So here we have f of x is equal to log of 1 plus x by 1 minus x. G of x is equal to 3x plus x cube by 1 plus 3x square. Then f of g of x is equal to how much? Again, the same thing. We have done so many questions in NCERT. Also, we have seen just before also we have seen just f of g of x we have to find. So first replace the inside function. If you are replacing the inside function, x cube by 1 plus 3x square. And this you have to put it in x, right? So therefore 1 plus 3x plus x cube by 1 plus 3x square. Directly you can write this itself because you know what is f of g of x. This will go here, and wherever x is there in f, there you have to put this one. So directly you can write this. So 1 minus 3x plus x cube by 1 plus 3x square. And after that, the same thing. You will take LCM in the numerator, in the denominator. Numerator's denominator, denominator's denominator will get cancelled. So once they get cancelled, what will you have here? See, this is looking like a formula only. X cube plus 3x plus 3x square plus 1. See? That's what we'll get. Okay, let me write it. 3x plus x cube divided by 1 plus 3x square. That will get cancelled. 1 plus 3x square minus 3x minus x cube. So this is straight away looking like a plus b whole cube formula. A cube plus 3a square b plus 3ab square plus b cube. So therefore, this will be log of x plus 1 whole cube. Okay, next, here also, means here this is playing the role of a cube plus 3a square b. So here, if we are taking one minus common, x cube minus 3x square plus 3x minus 1. Straight away you can see this is x minus 1 whole cube formula. X minus 1 whole cube. X cube minus 3x square into 1 plus 3x into 1 square minus 1 cube. Correct? So therefore, let me just write it for you here. A cube minus 3a square b plus 3ab square minus b cube. Here we have x, here we have 1 for this one. So therefore, minus of x minus 1 whole cube. Okay. So that's it. So we want it in terms of f of x. F of x as 1 plus x and 1 minus x. So because I want it in terms of 1 plus x and 1 minus x, I will write this as 1 plus x whole cube. And I can take this minus inside, isn't it? If you are having minus a whole cube, then this is, because minus is raised to odd power, I can write this as minus a cube. Reverse is also true. If you have minus outside and odd power is there, you can take it inside and put the odd power. So therefore, here this will be 1 minus x whole cube. So we have a common power here, 1 plus x by 1 minus x whole cube. So this can come here. So if it comes here, this will be f of x. So 3 into f of x is the answer for this question. Simple, isn't it? So we have to just, means by seeing this only we can make out a cube is there, 3x is there, right? So therefore, a plus b whole cube formula, a minus b whole cube formula. That's all, right? Simple. So that is how we have done the CET questions on composite functions.